Welcome back to Math 103. This is video number 12 on apportionment. Now we investigate some alternatives to Hamilton's method. Now Hamilton's method divides the state populations by the standard divisor to find the standard quotas and then rounds in a certain way. It rounds everyone down to their lower quota and then gives out surplus seats. Now the alternatives we will consider are all modified divisor methods. Right, so what does that mean? A modified divisor method divides state populations by modified divisors. These are numbers that are usually slightly different from the standard divisor, and the result is not the standard quotas, but rather modified quotas, which are then rounded in a certain way, and how exactly they're rounded depends on the method. So we're going to look at three methods, all of which have been used in American history, just as Hamilton's method was. So there's Jefferson's method, which was the very first apportionment method used in American history. Then Webster's method, and finally the Huntington-Hill method we'll consider, and that is the one that is currently in use. This will be easier to understand if we explain with an example. The following example is going to illustrate Jefferson's method. Now, I realize that we've been jumping around back and forth between different examples in this chapter, but there's a reason for it. So let's recall the example of the New England legislature after 20 years with 37 seats, and therefore a standard divisor that we can compute. Okay, this was the example where the total population had risen to 17 million. So 17 million people total, spread out among 37 seats, 37 congressional district, means that the average congressional district is home to 459,459 people. If you compute this, you'll find that there is some decimal part here, but we'll just round to the nearest person. That'll be fine. So we have our state populations and our standard quotas that we computed earlier, and the lower quotas, which, as we saw before, add up to only 35. And so Hamilton's job was to take the two surplus seats and give them out to the states that had the highest decimal parts. Okay, and those were New Hampshire and Maine. So at the end of the day, New Hampshire and Maine are happy with this arrangement, but arguably the other states have a certain resentment that they're stuck with their lower quotas while their two neighbors get their upper quotas. Now, if only we could somehow give every state its lower quota, instead of giving some their lower quota and others their upper quota, we might eliminate or reduce this envy provoked by Hamilton's method. Right? But we can't just do that, because as we've seen, giving every state its lower quota will leave us with two surplus seats, and that's not acceptable. Right? You can't just stop here, giving each state its lower quota. You must allocate all 37 seats. Now, suppose that someone comes along, someone named TJ, very bright guy, and suggests what seems at first like a bizarre idea. The bizarre idea is, nudge the standard quotas a little bit higher. If we can just nudge the standard quotas a little bit higher, by just the right amount, the resulting lower quotas actually would sum to the required 37 seats, right? So they don't sum to enough right now, but if we just nudged them a little bit higher, they would add up to 37. All right, so that sounds nice. How do we do this? What does it mean to nudge the standard quotas a little bit higher? Well, the idea is that instead of dividing state population by standard divisor, you divide state population by a number slightly less than the standard divisor. Slightly less. So think about it. If your cookie cutter is producing too few cookies, then using a smaller cookie cutter produces a greater number of cookies from the same amount of dough. So the state population divided by a smaller number will produce larger quotas. Right? So the new number we're going to divide by here, when we do state population divided by something smaller than the standard divisor, we'll call that a modified divisor. So we're still going to compute state population divided by some kind of divisor. That's why we call it a divisor. Now it's the modified divisor. That sounds great. We divide each state population by some divisor less than the standard divisor. But how do we come up with this new modified divisor? How do we know what we should be dividing each state population by? Now I have to admit to you, this is fundamentally a guess and check method. Right? It turns out that there is not as much guessing and checking as you might fear when you hear the words guess and check, and in practice, I am going to be suggesting to you a short list of candidates for what number you should be using as modified divisor. So for right now, let's try 400,000. It's a reasonable choice because it is less than, but not dramatically less than, the standard divisor, which was about 460,000. So let's try this out. Let's see if it works. In other words, we're going to compute state population divided by 400,000, and we're going to do this for every state, and we're going to see how much the modified quotas are, the modified lower quotas. So it turns out that 7 million divided by our modified divisor equals 17.5, and the modified lower quota is that 17.5 rounded down to 17. Great. Let's do Connecticut also. So 3.8 million people, instead of dividing by the standard divisor, we divide by 400,000. Okay. And we obtain 9.5. Great. So the modified lower quota will be 9. Just to illustrate one other point, for Maine, where we have 2 million divided by 400,000, that turns out to be an integer. That comes out to be exactly 5. And it's important that when you have, just by chance, an integer as your modified quota, the modified lower quota is itself. Right? When you have a whole number and you round it, that means you leave it alone. Right? That when you're rounding to when you round 5 down to the nearest integer, that means you leave it alone. You do not reduce it to 4, you leave it alone as 5. We can carry this out for all 6 states. We find the modified lower quota for each one just by rounding down to the nearest integer, leaving that 5 alone as 5, and add them all up. What do we get? We get 40 seats given out. All right, so we've apportioned too many seats. That's okay. This is a guess and check method. We've guessed, we've checked, and we've discovered 400,000 as a modified divisor does not give us an apportionment of exactly 37 seats, and therefore we need to try a new modified divisor. But that was not a waste of time what we just did. Finding out that 400,000 didn't work, and finding out how it didn't work, does actually tell us something about where to look for our next guess. So before going on to the next video, answer the following questions. Was our guess of 400,000 as modified divisor too high or too low? And therefore, should our next guess be greater than or less than 400,000?